Students, let us start amines compound. Today we will discuss about the preparation of amines. Preparation of amines contain here two types: reduction of nitro compounds by reduction of nitro compounds and by ammonolysis of alkyl or aryl halide. Here first we take reduction of nitro compounds. Whenever we are taking nitro compounds like nitrobenzene and hydrogenation reaction, reduction reaction is taking place. That means H2PD. You can use here NiPT or PD. Three metal you can use. Whenever nitrobenzene get reduced by passing hydrogen in presence of nickel metal, platinum metal or palladium metal and in presence of ethanol, then nitro compounds are reduced and makes amine. So we can obtain aniline. Here nitrobenzene and here aniline is produced as a yield. So we can say that when nitrobenzene get reduced by passing hydrogen in presence of nickel metal, platinum or palladium metal and in presence of ethanol, then nitro compound get reduced and forms aniline. So we can say that reduction of nitro compounds we can obtain amine compounds. Now second one, nitro compounds are reduced. Nitro compounds can be reduced by metal HCl, metal, Sn metal you can use or Fe plus HCl. Here you can use SnHCl or FeHCl. The mixture of SnHCl and FeHCl are added to nitrobenzene. That means nitro compounds are converting to amino compounds. Why? Because Sn plus HCl, the mixture of Sn plus HCl and mixture of Fe plus HCl, which is reducing agent. Now here you can use the word Fe. This is not Fe, this is iron scrap. This is iron scrap. So we can say that when nitrobenzene is to be taken and the mixture of Sn plus HCl or iron scrap plus HCl, so we can obtain nitrobenzene to aniline. Now we can say that nitro compounds are reduced to amine compounds. This is my aniline. This is nitrobenzene. Here Fe plus HCl, the process of Fe plus HCl is preferred. Sn plus HCl is also used, but Fe plus HCl process is more preferable because by Fe plus HCl we can obtain FeCl2 and they form HCl very easily. That is why we are using the iron scrap plus HCl. Okay, so we can say that here nitrobenzene is get reduced by passing hydrogen in presence of NiPT/PD and ethanol. We can obtain aniline, as well as nitrobenzene is reduced to aniline by using Sn plus HCl or Fe plus HCl. Second one, by ammonolysis of alkyl or aryl halides. What we have to do? We have to make amines compound, preparation of amine compound, and second reaction is by ammonolysis of alkyl or aryl halides. Now we will discuss about this. First of all, we are having Rx and we used ammonia in presence of alcohol, ethanol. So what will form? When alkyl halide reacts with ammonia, then HX will be removed and RNH2 is formed. This is my primary amine. This is my 1 degree amine. Okay, thereafter what? This is alkyl halide. So we can use the word alkyl halide reacts with ammonia in presence of ethanol, then primary amine is formed. Now here alkyl halide is used as a substrate. Here Rx will be your substrate and ammonia will be your nucleophile. So nucleophile will attack toward the substrate and forms HX. You can use HX and forms primary amine. You can see primary amine is also nucleophile because they possess nitrogen, and nitrogen is having non-bonding electron pair, lone pair electron. So here excess alkyl halide is to be taken. Then what will form? This is nucleophile. This is nucleophile. This is substrate. So nucleophile will attack toward the substrate and forms secondary amine. How it is possible? We can say H and X will be removed and HX will be removed and R will be going toward N. So R, NH, R. This is secondary amine. This is secondary amine. Now, secondary amine possesses nitrogen and nitrogen is having lone pair electron, non-bonding pair electron. So, it reacts with excess alkyl halide. Excess alkyl halide. Now, hydrogen and halogen will be removed and R will be going toward N. So, tertiary amine is formed. Now friends, this is tertiary amine, 3 degree amine. So we can say that when alkyl halide reacts with ammonia and ammonia will react like nucleophile, that is why 1 degree amine is produced. 1 degree amine, which is also nucleophile, reacts with excess alkyl halide and forms secondary amine. Now secondary amine is also nucleophile, so this will react with excess amount of alkyl halide and forms 3 degree amine. And thereafter excess amount of Rx. Reactions should not be done because nitrogen does not having hydrogen. But here what will happen? Now N and X will form like this type of structure. Here your tertiary amine, right? Now your R will be going toward N because nitrogen is having non-bonding electron pair, so they forms coordinative covalent bond with R. Nitrogen donate the electron to the alkyl and here X will be outside of this box, right? This is 4 degree ammonium salt. This is quaternary 4 degree ammonium salt is formed. So by this process we can say that 4 degree ammonium salt is obtained. First we will take alkyl as ethyl and halogen will be like chlorine. So this reaction can be carried out in Ca3, Ca2, Cl. Now ammonia will react. You can use 2 ammonia, 1 ammonia you can use. Here nitrogen is having non-bonding electron pair in presence of ethanol. When ethyl chloride reacts with ammonia in presence of ethanol, now ammonia reacts like nucleophile and ethyl chloride reacts like substrate. So it is my substrate, ethyl chloride. Now H and H will be removed and CH3, CH2, NH2 is formed. This is ethanamine. This is my 1 degree amine. Thereafter we will use excess amount of ethyl chloride. So by reaction with excess ethyl chloride is to be taken with ethanamine, then H and Cl will be removed. That is why diethyl amine is formed. So here CH3, CH2, CH3, CH2, NH is formed. So we can say that here ethanamine is also nucleophile and reacts with this substrate, and HCl will be removed. That is why secondary amine is obtained. Thereafter excess ethyl chloride is to be taken. Then here secondary amine is also nucleophile. That is why H and Cl will be removed and forms tertiary amine like triethylamine. So we can obtain CH3, CH2, CH3, CH2, CH3, CH2, and N is common. So it is my tertiary amine. So we can say that when ethyl chloride reacts with ammonia in presence of ethanol, then ethanamine is obtained. This is nucleophile. Ethyl chloride, excess ethyl chloride is to be taken. Then 2 degree amine like diethylamine, 3 degree amine like triethylamine, and if excess amount of ethyl chloride is to be taken, then quaternary 4 degree ammonium salt is also obtained. So we can have CH3, CH2 4 times N, and outside of this bracket we can use Cl minus as a negative charge and N is having positive charge. So this is my 4 degree salt, 4 degree ammonium salt. So we can say that ammonolysis of alkyl halide, by ammonolysis of alkyl halide we can obtain amine compounds. Now this reaction is reactive. Whenever we are talking about halide compounds like Ri, because the atomic size of I is more than Br and Br than Cl, so we can say that more atomic size of Ri will more reactive. So we can say that whenever we are talking about ethyl halide or alkyl halide, whenever we use Ri, the reaction will be very fast because the atomic size of I is more than Br and Cl. So we can say that the reactivity, order of reactivity of halide in this compound Ri will be more and RCl will be less. This is by ammonolysis we can obtain amine compounds. Now once again, reduction of nitro compounds. Let us talk about reduction of nitro compounds. When nitrobenzene is to be taken in presence of H2PD ethanol, then aniline is obtained. That means when H2 is passed, hydrogen is passed in presence of nickel metal, platinum or palladium with nitrobenzene, we can obtain aniline, aminobenzene or benzeneamine. Thereafter, whenever nitrobenzene is to be taken in presence of metal HCl like Sn plus HCl or Fe plus HCl. Now what is Fe? Fe is nothing but the scrap of iron metal, NaHCl, will convert to aniline. So this is the preparation of amines. Okay. Now friends, we are going further. Preparation of amine. Reduction of nitrile. By reduction of nitrile and by reduction of amide will be discussed. Here, nitriles can be written like this. This is nitrile. It can be written and it can be said like cyanide compounds. It is cyanide or nitriles. Now cyanide compound get reduced by catalytic reduction. H2Ni, you can use catalytic reduction, or you can use lithium aluminum hydride, or you can use sodium amalgam NaHg with ethanol. By three process, you can make cyanide to amine. So here 4H will be going toward cyanide. Now here 4H will be going towards cyanide. So carbon will take 2 hydrogen and nitrogen will take 2 hydrogen. That is why RCH2NH2 is formed. This is my primary amine. So we can say that this process is used for getting primary amine. Here, nitrile compound when reacts with nickel H2 or lithium aluminum hydride or sodium amalgam with ethanol, then hydrogenation is taking place, reduction is taking place. That is why carbon will take 2 hydrogen, nitrogen will take 2 hydrogen. That is why primary amine is formed. So this reaction is used for making primary amine. Now we will discuss about the examples. Here R is given whenever we are taking CH3 C triple bond, and this reactant will be used. Now what will form? Here carbon will having 2 hydrogen, nitrogen will having 2 hydrogen after reduction, and get CH3 CH2 NH2. So this is ethanamine. This is ethanamine. Now this is methyl silane or ethane nitrile. This is my ethane nitrile. So we can say that when ethane nitrile reacts with NiH2 or lithium aluminum hydride or Na-ethanol, then reduction is taking place. That is why 1 degree amine like ethanamine is formed. And if we are having ethyl group over here, then CH3 CH2 should be placed. Okay, CH3 CH2. Thereafter Cn is as it is. So we can say that when propane nitrile is to be taken and this reaction is carried out, that is why propane 1 amine is formed. Here carbon will take 2 hydrogen, nitrogen will take 2 hydrogen. That means we can obtain CH3 CH2 CH2 NH2. This is 1 propanamine or propanamine. 1 propanamine. So we can say that when cyanide or nitrile compounds get reduced by catalytic reduction or by lithium aluminum hydride or by Na amalgam and ethanol, then 1 degree amine is obtained. So this reaction is carried out for making primary amines. Now friends, we are going reduction of amides. By reduction of amide compound, we can also obtain 1 degree amine, primary amine. Here we should have RCONH2. This is amide. This is cyanide, this is amide. And reaction with only and only lithium aluminum hydride, and thereafter by hydrolysis we can obtain primary amine. How it is formed? Let me check. When amide reacts with lithium aluminum hydride and thereafter by hydrolysis, here 4H is used. Now 2 hydrogen will going with oxygen, that means H2O is formed, and 2 hydrogen will going inside. 2 hydrogen will remove with oxygen, so water will be removed, and 2 hydrogen will going toward carbon, so RCH2NH2 will be formed. This is my 1 degree amine, primary amine. Now friends, we can say that when amide reacts with lithium aluminum hydride, which is highly reducing agent, this is my highly reducing agent substance. When amide reacts with highly reducing agent substance like lithium aluminum hydride and get hydrolyzed, then primary amine is formed. Okay, now here R will be like methyl and ethyl, so methyl will be taken, then CH3CONH2 is formed. This is 2 carbon having name ethane, and this amide, that is why ethaneamide is formed. This is ethaneamide. Now reacts with lithium aluminum hydride, and thereafter by hydrolysis we can obtain ethaneamide. Now in this reaction 4 hydrogen will going inside, that is why 2 hydrogen will remove with oxygen, 2 hydrogen will remove with oxygen, and 2 hydrogen will going toward carbon. That is why CH3, CH2, NH2. This is my ethaneamide. Ethaneamide convert to ethaneamine. This is my amide group and this is my primary amine group. So ethaneamide reacts with lithium aluminum hydride, then ethaneamine is formed. This is my primary amine. Now we are moving from CH3 in place of CH3CH2. CH3CH2 CONH2. That means here you are given 3 carbon and amide. That means propanamide. This is my carbonyl group. Propanamide. When propanamide reacts with lithium aluminum hydride and thereafter get hydrolyzed, then propanamide is formed because 4H will be going inside. Among this 4H, 2H will be removed with oxygen and 2H will be going toward carbon. That is why CH3, CH2, CH2, NH2 is formed. This is my 1 degree amine, propane 1 amine. This is 1 number carbon, 2 number and 3 number. 1 propanamide you can say. Or other word, propane 1 amine. So we can say that by reduction of amide, we can convert the amide to amine. And here by reduction of nitrile, we can convert to primary amine. Both this reaction is for using for making primary amine. Here reduction of nitrile when cyanide is to be taken and NiH2 lithium aluminum hydride or Na amalgam with ethanol is used, then primary amine is formed. And here whenever amide is to be taken with lithium aluminum hydride, which is your strongly and highly reducing agent, that is why primary amine is formed. So we can say that both this reaction is used for making primary amines. Okay. Let us discuss about preparation of amine. Now we are moving for Gabriel-Thalamide synthesis. By Gabriel-Thalamide synthesis, we can obtain primary amine as well as aliphatic primary amine. This process is used for only and only for making primary amine. Now we will discuss about that. First of all, when benzene to neighboring carbon which are having carbonyl group, and these two carbonyl which attach with NH, this is attached by amine. This substance is known as phthalimide. Phthalimide. Now, phthalimide reacts with ethanolic KOH. This is ethanolic KOH. Now, phthalimide reacts with the mixture of KOH and ethanol. That means ethanolic KOH. Then what will form? This hydrogen will remove with of OH, so water will be removed, and potassium will be going toward nitrogen. That is why potassium phthalimide will be obtained. In other words, potassium salt of phthalimide is obtained. So we can write this is potassium salt of phthalimide. Potassium salt of phthalimide is obtained. After getting this substance, we will take alkyl halide. So what will form? Now K will be removed with halogen, so KX will be removed, and alkyl group will be attached with nitrogen. So we can obtain this is alkyl group attached with nitrogen. That means the name will be N-alkyl phthalimide. N-alkyl phthalimide. So here, when phthalimide is to be taken with ethanolic KOH, then potassium phthalimide will be obtained. Thereafter, by adding alkyl halide, KX will be removed. That is why N-alkyl phthalimide will be obtained, and thereafter reaction with NaOH is carried out. Then what will form? This group Rn will have two hydrogen. Rn will have two hydrogen. That is why RNH2 is formed. This is my primary amine. This is my 1 degree amine. remaining part of this molecule like ONA will be attacked toward this carbon and attacked toward this carbon. That is why the substance sodium thalamide will be obtained. This is sodium thalamide. Okay, so we can say that by this reaction we can obtain 1 degree amine, and this is aliphatic primary amine. Okay, now what we see, thalamide when reacts with ethanolic KOH then forms potassium salt of thalamide, and thereafter reaction with alkyl halide, then an alkyl thalamide is obtained, and after this product will be obtained, NaOH solution is added toward an alkyl thalamide, then primary amine is formed. So this reaction is for only and only for making aliphatic primary amine. So the question is arised that why aryl amine does not form in this reaction. Let's discuss about this thing. Here alkyl halide reacts with potassium salt of thalamide. This is your nucleophilic substitution reaction. Nucleophilic substitution reaction. But when aryl halide is given, this, if we are taking aryl halide over here, then the reaction does not carried out with the anion of thalamide, because aryl is there. That is why aryl group does not react with anion of, that is N minus, anion of thalamide. So the anion of thalamide does not react with benzene ring. That is why nucleophilic substitution reaction does not taking place. That is why we can say that aromatic 1 degree amine, aromatic primary amine does not form in this reaction. Okay, so we will discuss about one example. This is thalamide. Thalamide when reacts with ethanolic KOH, then HOH will be removed. That is why potassium salt of thalamide is obtained. Thereafter methyl chloride is added, then KCl will be removed. That is why N-methyl thalamide is obtained. This is N-methyl thalamide. Methyl is on the nitrogen atom. So N-methyl thalamide is obtained. After production of this substance, we can use 2 moles of NaOH. That is why this group will be removed with 2 hydrogen. 2 hydrogen will going toward this nitrogen and forms CH3 and 2 hydrogen, CH3NH2. This is my primary amine. This is my product, major product. And now ONA will attack toward this, both this carbon. That is why so we can say that by this reaction we can obtain methanamine as well as ethanamine as well as propanamine, but aniline does not form by this reaction. So we can say that Gabriel thalamide synthesis can be taking place for methenamine and ethenamine. Okay. Thereafter, friends, we are moving for Hoffman bromide degradation reaction. Now, in this reaction, we can obtain primary amine from amide compounds. Let us discuss about that. RCONH2, this is amide compounds, reacts with the mixture of Br2 plus 4NaOH, which should be aqueous or alcoholic. Ethanolic or alcoholic. When amide compounds reacts with the mixture of bromine and sodium hydroxide, which should be aqueous or alcoholic, then what will form? Then 2Na and 2Br will be removed. So we can use 2NaBr plus. Now 2Na is remaining 2Na reacts with CO and 2O, that is why they form Na2CO3. Remaining 2 sodium reacts with CO and 2 oxygen more, that is why Na2CO3 is formed, and remaining 4 hydrogen will make water. So here CO will be removed, 2Na and Br will be removed, Na2CO3 will be removed, thereafter water will be also removed. So what will form? Alkyl and amine will attach and forms RNH2. Right? This is primary amine. This is 1 degree amide. This is amide. In 1 degree amine product, the yield contain less number of carbon. Less number of carbon is in this amine because amide is having CONH2 group. Now we can say that amide reacts, amide compound, whether it would be aliphatic or aromatic, amide compounds reacts with the mixture of bromine and NaOH, which should be aqueous or ethanolic. Then NaBr is formed, Na2CO3 is formed, and water is formed. That is why RNH2 will remaining part, so they form primary amine. So we can say that when amide reacts with the mixture of aqueous or ethanolic Br2 and NaOH, then form primary amine. This reaction is known as Hoffman bromide degradation reaction. This reaction is used for getting one less number of carbon into the yield. Okay, we can say that here aliphatic amide and here aromatic amide will be taken. CH3 CONH2 reacts with the mixture of Br2 plus 4NaOH when ethanamide, this is my 2 carbon and amide, ethanamide. When ethanamide reacts with the mixture of Br2 and NaOH, it should be ethanolic or aqueous. When ethanamide reacts with the aqueous or ethanolic Br2 and NaOH mixture, then this CO will be removed and methylamine will be formed. So this is methenamine or methylamine. Methenamine. So methenamine is formed from ethanamide. So we can say that ethanamine is formed by propanamide. So we can say that here CH3, CH2, CONH2, and this mixture is to be taken. Then CO, carbonyl group, will be removed and forms ethanamine. So here one less carbon will be obtained in amine compounds. This is ethanamine. Right? So this is propanamine. So this is my aliphatic amide. Ethanamide and propanamide reacts with the mixture of Br2 plus 4NaOH. Then methanamine and ethanamine is obtained. By this reaction, we can have one less number of carbon in amide than that of amide. Now here we will take aromatic amide. This is my benzamide. Benzene and amide will attach, that is benzamide. Benzamide reacts with the mixture of Br2 plus 4NaOH, which should be aqueous or alcoholic. It should be aqueous or alcoholic, ethanolic. So benzamide reacts with the mixture of ethanolic Br2 plus 4NaOH, then forms benzenamine. This is aniline or benzenamine. Benzenamine or aniline. Now what will your side product will be? Na2CO3. Side product will be NaBr, 2 moles of NaBr and 2 moles of water. Here also you can say that minus Na2CO3, minus 2 NaBr and minus 2 water. So we can say that when amide compound is given with the mixture of alcoholic Br2 plus 4NaOH, then they form primary amine, and this 1 degree amine, which should be aliphatic amine or aromatic amine, and the product which can have one less number of carbon than that of amide. So this is your Hoffman bromide degradation reaction. Okay.